Well, hello and welcome to this What Problem Part 7. This time it deals with direct proportion, indices, and substitution. There is also simultaneous equation involved, suitable for higher tier iGCSE, GCSE, probably additional maths, and certainly for 10th grade mathematics and 11th grade, perhaps 11th grade algebra as well. And what you've got here is a cutting rod manufacturer tests its cutting rods by measuring the sag at the center before failure occurs. Now his results are shown below, and we got the length of the rod x in meters there, and the sag in the middle by y in millimeters there. Okay, and he then says he knows that y is proportional, in other words the sag is proportional to the length of the rod raised to the power n, where n is a positive integer. And he says find n and check your answer. Now firstly we copy this down. We got y is proportional to x to the power n. We then replace this sign of proportionality with an equal sign. We then have y is equal to k times x to the power n there, where k is a constant of proportionality. Now I'm aware here that the length is in meters and the sag is in millimeters. Now when we do our calculations, we find that they will cancel up, so don't worry about that for now. Okay, now secondly, we've got two unknowns. We've got k, I've got n. We don't know k, we don't know n. So x is in this row here, so x can be 1 there. So that sounds interesting, because 1 to any power will give us 1 there. So I might use this ordered pair of 1.5 there to form our first equation. Now secondly, I got 2 and 4 there. We can raise 4 is the same as 2 squared, or 2 to the power 2, and 1 is 2 to the power 1. So that might be interesting to use that one as well. That's a bit more difficult, this one here, 313.5. That's interesting. I could use 2 squared and 2 to the power 5 there, which is 32. So can I use either this one or that one? It seems a bit of thinking to do that. Alright, so these are now our equations. For equation 1, using this ordered pair here, a half, which is y, is equal to k times 1 to the power n. That's equation 1 there. Now my equation 2 will be this one here, this ordered pair. 4 is equal to a k times 2 to the power n. If we then divide equation 2 by equation 1, we have this here. Okay, now I know this is 0.5, which is the same as a half there. So 4 over 0.5, so 4 millimeters over 0.5 millimeters. The millimeters will cancel out, and k times 2 to the power n. Now 2 will be in meters there, so they will cancel out again. And 1 to the power n is 1. And the k's will cancel out, as we see there. So we end up with 4 over 0.5 is equal to 2 to the power n over 1. And when we cross multiply, we have that 4 is equal to a half times 2 to the power n. Okay, so this one here is same as saying 2 to the power n divided by 2. And of course, when you divide indices, we have that as 2 to the power n minus 1 there. So 4 is equal to 2 to the power n minus 1. So we know 4 is 2 squared, so 2 to the power 2 is equal to 2 to the power n minus 1. So that means that 2 is equal to n minus 1, and n is 3. Now, it says check your answer. Now, what this is saying to us here, we need to find the value of k before we check our answer. Okay, so that's a cunning way of saying what is k. Right, now, we know that n is 3, so if we substitute the value of n is 3 into equation 2 there, we got that 4 is equal to k times 2 to the power 3, because n is 3 there, which is the same as saying 4 is equal to k to the power 3, and 4 is k, which means that k is equal to divide 4 by 8, which is the same as a half. So k is a half. Now to check, if we use this one here, which is a bit difficult, use this other pair of 3 and 13.5. So 13.5 is equal to a half because k is a half, our x is 3, and we know n is 3 as well. So a half times 3 cubed. Now 3 cubed is 27 because 3 times 3 times 3 is 27. Divide 27 by 2, we have 13.5. So the left hand side and the right hand side do balance. So we're right. Now I hope all that made some sense. Please subscribe, and thank you for watching. Hopefully see you again sometime. Bye bye now.